Okay, so back to example number 4 that we were doing the last day. So it's a 25 kilogram box. It's being pushed across the floor with a horizontal force of 180 newtons. Coefficient of friction is 0.422, and it wants to know what's the acceleration of the box. So our 3 steps: sum of the forces in the y, sum of the forces in the x, and FFR equals mu Fn. Usually we always start with sum of the forces in the y, and then which one of the other two we do first depends on what we're given. So first, let's start with sum of the forces in the y. So this box that's being pushed across the floor isn't moving in the y direction, so this goes to 0. And the forces we have in the y direction are Fn going up and Fg going down. And if we call up positive, then it's Fn minus Fg. So Fn equals Fg equals mg. So Fn equals 25 kilograms times 9.81 meters per second squared. So Fn equals 245.25 newtons. All right, so we have our Fn. Now we look over at what we're given and we realize we're given mu. So because we're given mu, this time we can find friction right away. So our step 2 can be FFR is equal to mu Fn. So friction is equal to 0.422 times that 245.25 newtons that you just found. Do the math and find out that you have a force of friction of 103.4955 newtons. Okay, so this is our frictional force. So now we want our final goal is the acceleration in the x direction. So we can do sum of the forces in the x is equal to max. This time the ax is in 0 is what we're looking for. What are our forces in the x? We have F going one way and friction going the other. So F minus friction equals max, divide both sides by m. So ax equals F, which is 180 newtons, minus friction, which is 103.4955 newtons, divided by our mass, which was 25 kilograms. And so you get an AX of 3.06018 meters per second squared. Final answer. Okay? So that's example 4. Good news, I have a couple more. Just because I think if you, oops, that was example 1. I think I'm hoping that as you watch me do these and try them yourselves, that you'll see that it's always the same steps, just the order. So number 5 says the 60 kilogram box is being accelerated across a level floor at a rate of 2 meters per second squared. All right, so 60 kilogram box. Sorry, my printer was having an issue. There's a force going this way. There's Fg acting down. There's Fn acting up. And friction's going this way. So it says it's being accelerated across the floor at a rate of 2 meters per second squared. So Ax is 2 meters per second squared by a force that is 220 newtons. What is the coefficient of friction? So we're looking for mu. So starting with our sum of the forces in the y direction is equal to may. It's not moving in the y, so this goes to 0. So we have Fn minus Fg is equal to 0. So Fn equals Fg equals mg. So Fn equals 60 kilograms times 9.81 meters per second squared. So we have an Fn of 588.5 8.6 newtons. I think we've been here before. All right, question wants to know what is mu, which means we can't go and find friction yet by doing mu Fn, so we have to do sum of the forces in the x direction. So in the x direction, we have F, sorry, it's the light reflecting off my hand that's making this glare, minus friction is equal to max. And this time we're finding friction because we know F and we know A. So bring your friction over, bring your max over. So F minus max equals friction. So friction is equal to 220 newtons minus 60 kilograms times 2 meters per second squared. So friction is equal to 220 newtons minus 120 newtons. So friction is equal to 100 newtons. Okay, and then once we have that, we can do FFR equals mu Fn as our third step. So mu is equal to friction divided by Fn. So mu is equal to 100 newtons over 588.6 newtons, and that gives us a mu of 0.1699. All right, getting the hang of these? Number 6, a cart is being pushed across the floor by a 300 Newton force acting parallel to the floor. The coefficient of friction is 0.32492, and the cart accelerates at a rate of 1.5 meters per second squared. What is the mass of the cart? I threw you a wrinkle. Okay, so here's my cart. I don't know its mass, but I know I'm pushing with a force of 300 newtons. We know there's an Fg acting down. We know there's an Fn acting up. We know friction is acting backward. We know that Ax is 1.5 meters per second squared. And we know that mu is 0.32492. And we're looking for m. So now you might start this and say, I don't know what to do because I don't have the mass. Whenever you don't know what to do, the answer is sum of the forces in the y direction. Okay, so it doesn't change. We're starting with sum of the forces in the y direction. Still not moving in the y, still goes to 0. So Fn minus Fg equals 0. So Fn equals Fg. But this time, as far as I can get, is Fn equals mg. I cannot get a number for it. Now, the two options are give up or say, well, maybe it'll work out, and go to sum of the forces in the x direction. In the x direction, I have F minus friction is equal to max. But I don't know what friction is, and I don't know what m is. So over on the side, I can do, okay, friction is equal to mu Fn. So that means friction is equal to mu mg. Because down here I have Fn as mg. And now, where friction is, I can sub in mu mg. So I have F minus friction is equal to max. Whoops, I just had that. I have F minus mu mg is equal to max. Take your mu mg over, so F equals max plus mu mg, and then pull out the m. So F equals m brackets ax plus mu g, and now divide by the bracket. So m is going to equal F over ax plus mu g, and I'm going to run out of time. F is 300 newtons. A was 1.5 meters per second squared. 0.32492 times 9.81. And when you do the math, you should get 64 kilograms. Okay? And so now you can do tonight's homework on the sheet 127.